Alright, so we're talking about Lab 4. So what's the purpose of Lab 4? So we can examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. Principles are, fundamental principles are Newton's second law. Other important formulas we need to know is that F net is equal to the combination of the force of gravity plus our spring force. Here's the formulas down below. So we have spring stiffness, relaxed length, that all calculates into the force of our spring. Introduction of fundamental physics properties. So we know that the change in energy in the system has to equal our work in surroundings. And we know that based on that, we can set that equal to 0, so we know the change in kinetic energy and the change in work done by our system and the change in work done by gravity must equal 0, so we can just set those also equal to our system. Introduction, so we use tracker, obviously. I have my tracker right here. We use it to capture the motion in our lab. So it captures the movement as it goes in a circle. It captures our data in terms of position, and then we use GlowScript to predict the change in our positions and the change in energy based on time. Coming back over here, so we can go ahead and start with calculations. So we can find our spring stiffness based on the oscillations. So if we start at 0.95, which is where I started in the data because these first two data points I excluded, and then we find how many we've done. We've done three around the circles. At this time, we can set 3t equal to, we subtract t1 or t2 or t1 from t2 and we get 1.614. Then we plug that into the formula to find k because we know t is equal to 2 pi times square root of mk. That is then translated into 4 pi squared mass divided by t squared. So we're actually looking at our spring stiffness being 6.92 newtons per meter. Then we can figure out our L naught, or how long it's stretched. So we set that equal to each other, and we use L mag, or the magnitude of L as 0.7 meters. Yep, and then we go ahead and we plug that in. We find the initial position of our vector, so based on the initial point that we took related to this time. And then we come over here and we edit, so we use our spring constant that we found, and then we also use our previous L naught, and then we can plug that in and we can solve for the kinetic energy, gravitational potential energy, and spring potential energy, and then we combine all of those. So it's just in relation to these formulas back up here, put in terms that that the code would enjoy. Then we come down here and we edit this. So basically, we end up editing 90% of that. This is what our code outputs. As you can see, they all return to 0 at some point when they all attach to each other. And then we come over here and our graphs look about right, I believe. I'm not exactly sure. So what does all this stuff mean? It basically just means that is our system of energy satisfied? Yeah, it is. So the change in energy done by our system is 0. The sum of the Earth's spring and block are 0, so no work coming from the surroundings. Conclusion, there might have been some sources of error, probably from my code, probably human error, but yeah, I hope you enjoyed and have a great evening.